how would you age date, actually get a numerical age?
Magnetic.
Magnetic wouldn't work because granites have intruded and cooled and crystallized deeper in the crust. And so they don't have a magnetic signature, normal reverse kind of a magnetic. Lava flows can do that because they come out on the surface and but granites cool so slowly. So magnetic won't help you. What else? Okay, but carbon dating can only be used for organic material, but you're on the right track. There are other isotopes. Actually, potassium-40 to argon-40, and we have K feldspar in here. So that's a possibility, isotopic pair. Potassium-40 decays to argon-40 using a beta emission. There's uranium-lead, and there's also thorium-lead, and there's also rubidium-strontium. Each of those have pros and cons, different half-lives and things like that, and require quite a bit of lab work to do that, and of course the analysis, the mass spectrometer to do that work. This granite's never been done. So, in fact, none of the rocks out here have really been tested for the radioisotope ages, simply because it's costly. You know, per sample, you're probably looking at $500–600 a sample, and you may have to submit several different samples from slightly different localities, and you have to compare them and all that stuff. So if you were to do a complete isotopic analysis of all the rocks out here that can be tested using this method, you'd be in for $3,000 to $5,000 probably. Not in our budget. So what can we do? We can only look in the general region where other isotopic ages have been done, and maybe correlate to this granite. There's some this granite right here. Do you know where Black Hill is? On 8th Street and 2nd Avenue. You know where Roxaboxen is, where 8th Street is, and 2nd Avenue there, and you have that hill, and there's some towers. There's some towers up there. You know what? Right where those towers are, if you walk up there, this same granite is exposed right there. Beautiful. And that's been mapped and age dated, and they have a probable Precambrian age on that granite. Very old age on there. About 1.4 billion is that. And so we could suggest that maybe it's that old here too, because it's a very similar kind of granite. And so,
billion, you said, right?
Billion, yeah, we're very old, very 1.4 billion years old. Yeah. But I can, I don't want to confuse you, but we're in geology. This can happen. There are some other granites that are similar to this that are of Jurassic age, much younger. You know, the 160 million year time frame. And there's some over in the Cargo Muchachos in California, in that area, that have some similarities to these. But whether these are related to those or not, we really can't tell. We don't have any other field relationships. So we've been kind of thinking that we should go with the closer granite that has an age date on it that looks very similar to this. And so 1.4 billion seems to fit into the scheme of things. Another thing I might point out is that you'll notice that the rock. I'm surprised the air horn hasn't gone off.
Yes, we haven't heard it.
Yeah, because we've been more than 20 minutes.
We've been 27 minutes.
Yeah. I need to send you guys to. Well, we're gonna. No, because I'm going to have the stop 5 people coming, no, stop 1 people coming to me, and they're up there in the top. So I need to send them down here. Nevertheless, that's probably the age that most of the instructors are going to be using for this granite. There we go.